Hello, my name is Colin Chatburn. I'm here today to talk about catalytic converters. Catalytic converters basically look at cleaning the toxic gases produced from the engine through the emission system. What we're looking at here is taking some of the harmful gases away and producing something that's less harmful to the environment. The purpose of a catalytic converter is to convert harmful gases through a catalytic process into something less harmful. So the clue's in the title there. It's not a DPF, it's not an exhaust, it has its own role to play. Now, it's an important part of the modern vehicle through necessity in cleaning those harmful gases. But cleaning those harmful gases is actually now a legal requirement. And through government legislation, through a number of standards, through Euro 1, 2, 3, to currently Euro 6, we are having to work harder and harder at managing that gas flow. Catalytic converters basically came into function with the advent of Euro 3 legislation. There's a number of different Euro standards which OEMs are now required to meet, depending on the age of the vehicle. And it's on the introduction of those vehicles that the legislation has got more and more stringent. All replacement catalytic converters from 2001 on, in other words the Euro 3 standard, are required to meet Regulation 103. This is an EU government legislation measuring the outputs of the gas flow. Every few years since then, the EU regulations surrounding this emission system has got a little bit harder to meet, and we're now up to a Euro 6 standard. And actually what we're trying to do now is manage that gas flow in a very sophisticated way. As a part of this requirement, as a part of this legislation, the original equipment manufacturers and in the aftermarket, we have to produce parts of the consistent shape and coating to the original. Parts are approved by shape and coating on the vehicle to ensure that the harmful carbon monoxide, hydrocarbon gases are converted into the less harmful carbon dioxide gases, managing those hydrocarbons through the exhaust system. We have to meet predefined EU limits on the outputs from the gas stream in terms of the hydrocarbons and those NOx gases. This requirement in the aftermarket means an 8-week testing process costing about £20,000 per application. So it's quite a commitment to kind of achieve this standard. As part of that approval process, the testing authority, in many instances the VCA, TÜV, Inter, IDIADA, these government legislative bodies will stamp the product with an E number, and it's that E number on the can that signifies the testing criteria has been met. Alongside markings on the product itself, the manufacturers will also issue a certificate of homologation. The catalytic converter is one element of the emission control system, which converts those polluting, harmful gases into non-polluting gases. Catalytic converters convert this harmful toxic gas using heat. So the placement of the cat within the exhaust system is actually quite important. And what we've seen over time is that that placement has changed. So in the early models, what we saw quite commonly was an underfloor system, underfloor placement of the catalytic converter. As the requirements through those Euro standards has increased, what we've seen is the movement closer to the engine where the heat is generated of those catalytic converters. So we're now seeing a move more away from the underfloor, more towards a maniverter or a close coupled catalytic converter very close to the engine where it can use that heat. A catalytic converter is actually a flow-through device. If you think of the monolith, it's creating a surface area through a cellular structure. Think of a bundle of straws, and what it's designed to do is allow the gas to pass through that monolith, that construction, so that the gas touches lots and lots of the surface area. That surface area is coated with a precious metal, one of 3 precious metals, platinum, palladium, or rhodium. And those precious metals help convert those harmful gases into that less toxic gas. It's an important and essential requirement within the monolith that that loading is sufficiently high to allow that reaction to take place. Insufficient loading of those precious metals means that too much of the harmful gases will be emitted through the exhaust out into the environment. It's important to remember a catalytic converter is not a silencer. It is not a catch-all to ensure that a vehicle passes an MOT. It is just one component within the exhaust system. The majority of cat failures are not down to the catalytic converter itself. There is not an awful lot for the cat to go wrong. It is simply a flow-through device coated with metals that converts that gas. It has very little in way of moving parts. If a car is failing an MOT or exhibiting any other catalytic related problem, the general rule of thumb is to ask why that may be happening rather than simply replacing that cat. So a couple of key questions to ask when you're looking at cat failure. First of all, why has the cat failed? Is it indeed the cat itself that the problem lies within? Are there signals elsewhere within the system that we can use to try to identify the problem area? Do we have signs of soot or petrol in the pipework? Is the body blue in colour? Are there any signs of physical damage? Is there a problem elsewhere within the vehicle or its service history that may be presenting itself as a cat problem? And have the lambda sensors or other sensors within the systems recently been checked or changed? It might seem silly, but an obvious question: has the correct fuel been used? If there has been a misfueling, are there any legacy issues there that are presenting themselves as problems now within the cat? There are a number of reasons why a cat can fail though, and that tends to be down to physical damage. Now that might be down to impact or road damage, thermal shock for instance. Here we have some samples and we can see the effect that that has. You can see that there's been some erosion, some sort of splintering of the monolith that's then rattled around within the can and created this erosion effect. With this example, what we're seeing is some kind of overfueling or monolith melting kind of damage, clearly destroying the surface area. And as time goes on, you'll get shards within the brick that rattle and erode and damage the monolith construction even further. There can be other physical symptoms or physical faults through the use of contaminants, for instance. Exhaust paste used upstream of a cat will contaminate that monolith and create problems. The lack of new fittings when we install a new catalytic converter, or indeed an exhaust system, the lack of new fittings can create flex within the system, which again can cause physical damage within the cat. There is also the problem with melted monoliths. This monolith here, we've got a slightly different material, but it's the same kind of functionality. In this instance, we have a metal monolith. Again, it's trying to create a surface area for the precious metals and the gas to flow through. But on this metal monolith, we've got evidence of monolith fusion. The surface area has melted and created a problem. So we talked about some of the failures of a cat and why things go wrong. But in identifying the reasons for the failure, it's very, very important that we use a 4-gas analyzer to take the necessary readings and measures to allow us to interpret the fault. The parts per million of hydrocarbons actually permissible within the gas flow is set at around 200 parts per million. Actually, an engine fault will be signified within that hydrocarbon count at around 60 parts per million. So actually the testing tolerance is actually quite high. High hydrocarbon levels tend to suggest overfueling or petrol leaking into the exhaust system. And an increase of the CO levels from natural idle to fast idle will also indicate a misfire. So it's important to remember that we need to diagnose the reason for the failure rather than simply identify the cat as the fault and look for a replacement. We do have some common fault codes that we can perhaps look at. So you may have seen a P0420 code. Now this doesn't necessarily of itself signal a problem with the cat. What it suggests is a cat efficiency problem. But actually, that may mean that it lies in the area of the cat and the function that the cat is performing rather than a fault with the cat itself. So it's also important to look at some of the contributing factors that may be influencing this fault code. Intake air manifold leaks, fuel injector problems or leaks, misfueling, air leaks, incorrect spark plugs, timing issues, EGR valve problems. It may be a defective catalytic converter, but there may also be other contaminants entering the system, whether that's oil, antifreeze. Look at the sensors, look for physical damage, look for contamination. It may be that the cat is actually the victim of a problem elsewhere. I hope you found it useful. Thanks for listening.